So tan and cotangent. So tan, first of all, we want to know that tan is actually made up of sine and cosine. So tan theta is made up of sine and cos. Okay, so I need you to know that. I'm going to draw some stuff on the bottom of the page only because we have more room there, so I don't have to squish it up to here. So I'm going to take this tan and I'm going to draw it. I'm going to go all the way down here because we have a bunch of room here on the bottom. I'm just going to draw a line and then I'm going to draw some stuff there because I realize that I have a bunch of room here. I don't need to use a Post-it note. I'm going to draw it down here. Okay. So tan, so let's work out what tan's going to look like for a second. So I know that tan theta is made up of sine over cos. Okay. We know that when we graph any function, we know that when the denominator equals 0, that will give me what? Denominator equals 0, asymptote, vertical asymptote. So this one here, cos theta equals 0, that will give me my vertical asymptotes. Okay? When does cos theta equal 0? Well, I'm going to grab that. So I'm going to draw cos and sine. So I'm going to actually draw the sine one as well. So I'm going to draw that in a second. So I'm going to do this one. So my sine, orange shows up. You're okay with the orange? My sine, when I set the top equal to 0, what am I getting on a graph? When I do sine theta equals 0, what am I getting on the graph? The roots, right, exactly. So the x-intercepts or the roots. Okay, roots, x-intercepts. So then, I want to draw sine, and I'm going to draw cos just here on the side, just so we can picture it. I find it's easier for me to do it if I can picture it. I'm going to try to line them up so that you can see. I'm trying to line them up so you can see one above the other, right? And you'll see why in a minute. Okay, so watch. I'm trying to line them up. So 1, 2, 3, 4. I want to try to line them up just so you can see, and you'll see why in a minute, why I'm trying to line them up. See what I mean by line up? Okay, so I want to draw the sine on top of the cos. I find this way as I'm visualizing kind of what was happening. So sine will go from here up to 1, down, so I'm doing this, and then here. It doesn't have to be perfectly accurate, but just so I can compare the two graphs. And cosine starts here, up. Yep, what'd I do? Oh, shoot, I just started drawing sine again. Ugh. Sorry. That's me. I was saying cos and I drew sine. Thank you. Okay, so draw cos on the bottom one. Cos. Like that, just enough so that we can compare the two graphs one above each other, because we're going to do sine divided by cos. We're going to take these values and divide it by cos. And I find it easier when I picture it, what's happening. So wherever cos equals 0, we're going to put vertical asymptotes. So let's grab those, and we're going to grab these guys here. These are my vertical asymptotes. So where it equals, what's that going to be? Pi over 2 and 3 pi over 2. Right? So I want those to be my vertical asymptotes, and it repeats itself. So come on up here. Does that make sense? So I'm taking the denominator, which is cos. Wherever cos equals 0 are my vertical asymptotes. So let's go up to the graph now. Okay, we're going to do it step by step. So we grab this. And we do this. After you do this, then you kind of memorize what it looks like. But for the first part, it's kind of like, where did I get the numbers from? So I'm doing pi over 2 and 3 pi over 2. So I'm going to go tick, tick. I'm doing every 3 squares. I use that to be consistent. This will be my 2 pi. So wherever cos equals 0, so you can even picture, cos equals 0 is here. I'm starting here. It hit down at 0. So sometimes I go, okay, well, I'm just going to picture in my mind that cos was, but I don't want to mess up your graph, so I drew it separately. Whenever cos equals 0, right, look, picturing here, wherever cos equals 0 is here and here, that's my asymptotes. I just didn't want to draw all the graphs on top of each other, so does that make sense? So I'm going to take this one and go asymptotes. I'm going to do it in green this time. And it repeats itself, so on this side as well. So I'm going to do, and it's symmetric, see? And then I'm going to do every, is that okay? Okay. So wherever cos equals 0, so if you want to, you can picture. So cos is up here, it heads down to 0, and it goes up here. So that's my cos graph. Wherever cos equals 0, it's there. I just don't want to have overlapping graphs, because then it's too much, because you're going to have 4 graphs on there. Okay, now, what did I say about the top part? Wherever sine equals 0 is going to be roots. So let's go down to the, I'm going to zoom out for a second. Okay, so wherever sine, so come over here, wherever sine equals 0, it's the roots, the x-intercepts. So that would be here, here, here. And what values is that? 0, pi, 2 pi. 0, pi, 2 pi are where there's roots. So go back up here. Does that make sense? So the top 0, pi, and 2 pi are my roots. So we're going to go 0, pi, and 2 pi. Those are my dots. Those are my roots. And I know this is x, sorry, y, and this is x. I don't care where 1 is. 1 is not going to be significant. Where else do you think the next dot will be? Here, in between the two asymptotes. So you see the pattern? So once you get the pattern, you're like, oh, I know where it is. It's there. Okay. Now, how to get the shape of the graph inside. This part's the kind of a tricky part just at the beginning, and then you go, oh, I can just memorize this now. So once you get the parent function, you kind of get it done. So over here, when you are looking at sine divided by cos, so that's what tan is, you are taking this value. So I'm taking, so this is where my asymptote is. So this is y. So I'm going to say this is where my asymptote is. Okay? What's happening closer to my asymptote? And you can plug in a value. So remember how we have the limits? We can say the limit as you approach there and plug in some values. But I'm just going to do that here on the side now. So if I have sine, and sine is getting closer to what value? What value is sine getting closer to as I walk this way? 1. And here, cos is getting closer to 0, yes? When I'm close to the asymptote. Remember my asymptote's right here? That's why I want to show you the asymptote. So when I'm getting closer this way. So at this part of the asymptote, as I'm getting closer, can I choose a value that's close to 1? What's a good value close to 1? 0.99? Okay. What's a good value close to 0? Divided by 0.01, kind of matches symmetrical. What number am I going to get? 99. Okay, try it again. Get closer. What's a number closer to 1? 0.9999. Not. Yeah? All right, I'll stop. Okay? Divide by what's a number really close to 0, because this one's heading down to 0. 0.0000.
How do you know those points line up, though?
They don't. I don't care. I want an approximate. So remember, you're looking at what's happening to the graph. So as this point is getting closer to 1, can you argue that it's getting closer to 1?
Yeah.
No? You can't argue. You can't argue it's getting closer to 1. So choose a value that's closer to 1. Whether it's 0.9897 or 0.999 doesn't make a difference if you're dividing it by a really small number. What's the pattern? So I'm looking for the pattern, right? So it doesn't matter if that's 0.01, or sorry, I don't know how many zeros I went. I think I went 1, 2 more. 1 or 0.2, okay? But what's the pattern going to say? So if I put 102 versus 1, what are you seeing what's happening to the number? What are you seeing that's happening to the number, though?
It's getting bigger?
Yeah, so that's why. So you don't actually need the full value. You can plug in a value. So you can do sine close to 90, so sine of 89, divide by cos of 89, and get actual values. But what you're going to get is that the number's getting bigger.
So what if you did that, sine 89?
Yeah, so do that. So sine of 89 divided by cos of 89. Oh, I'm in radians, sorry. I think that's the wrong one. So, sorry. We want degrees. So sine of 89 divided by cos of 89. 57, degrees? Cos of 89, that should be closer to pi. Cos something 57, get closer. Okay, you got to get closer. So sine of 89.99, right? So you got to get closer. 0.9999, right? Divided by cos of 0.89. Oh, sorry. 89.999. There you go. 572,000. So same effect, right? So I'm doing it without doing the sine and the cos, but you're seeing as the number gets closer to 1, this number's getting closer to 0, you're getting 572,957. So same thing. So do you need to calculate it? No. You're looking for what's happening close to the limit, close to the asymptote, and the limit is that it's increasing. So once you see it's increasing, because that's a positive divide by positive, we go to the graph and we go, oh, you mean it goes up? Yeah, that's all. I don't want values. I want the shape. And here, what's going to happen here, so can you guess what's happening on the left side? The sine is heading negative. The cos is still positive. What's a negative divided by positive? It's going to be this way. And then people go, so it looks like a cubic? Yes, it looks like it's not a cubic, though. A cubic keeps getting wider. This is following an asymptote, but yes, it does look like a cubic. You were like, oh, can I just memorize it? I guess you can memorize whatever you'd like, but yes, it's supposed to follow an asymptote. So that's the shape we want. And then, does it follow the same pattern? Yes, it does, as you continue here, and we go like this. Does that make sense? So you can do decimals, and what you want is to get that behavior near the asymptote, etc. And it continues and continues. So that same pattern continues. Yes. Good? And that's it. So you want to memorize the shape, because we don't do values. So we just want the roots, and we want the asymptotes, and that's it. So just the shape. And we know that as you get closer, it's getting up, and as you get closer here, it'll go into the negatives. And yeah, you can try a number. So sine of negative 89.9999, you have to go to decimals, and divided by cos of negative 89.9999 will get you a big, big negative number. Okay? Let us answer all of the questions then.
No, sorry.
Okay, wait. Answer the questions first and then do the cotangent. Is that all right? Okay, so let's do this one first. So answer the questions first and then we'll do cotangent. So period is, how far do I need to go before I repeat myself? I just need 2 sections, right? And then repeats, how much is 2 sections? If 4 sections is 2 pi, then 2 sections would be pi, right? So I only need a pi section, right? So then my period is pi. Okay. My maximum, again, none. I don't know why I didn't put the asymptotes, so I'm sorry, that's by accident, but the asymptotes are going to be every odd pi. I'm going to use it here in the domain anyway. I don't know what happened there. I think I deleted it by accident. I have it here, right? Do you want it? Let's add it. Vertical asymptotes. I don't know what happened to it. I think it just got deleted by accident. So my vertical asymptotes would be every odd pi. Do you see the pattern? And that's from the cosine. So every odd pi, because this will be pi over 2, that's 3 pi over 2 for every odd pi. So again, it doesn't matter which way you do the equation, either one that we talked about on the last page. So we're going to do vertical asymptotes will be x equal 2k plus 1 pi over 2, where k is an element of the integers, right? So every odd. And then you take this answer, right? You take this answer for your domain, and we're going to say that my domain is x as an element of real, and x cannot equal the 2k plus 1 pi over 2, where k is an element, right? And your range is anything. There's no restriction on the range. It goes up and down forever. Okay, questions or clarification? We're good? Yes? When you have asymptotes, yeah. Vertical asymptotes, it just pulls it up and pulls it down, yes. Okay, so cotangent. So we're doing the reciprocal. So whatever we see here, we want the reciprocal. So what is the reciprocal of a 0? Reciprocal of 0 is a? Use pink. Asymptote. Right? We know asymptotes are zeros. I'm doing it in this big pink because I can't do it. It gets overlappy. Okay, so every one of these zeros is now an asymptote. Okay. What happens to an asymptote when you take the reciprocal of an asymptote? An asymptote is something over 0. When you take a reciprocal of an asymptote, it's a root, right? So remember we learned that wherever an asymptote is in a reciprocal, it ends up being a root. We did that with quadratics and stuff too, right? So wherever there's an asymptote is now a root. So I'm going to put a dot. I'm using the pink highlighter because I can't see anything else. So here. So wherever I see an asymptote, you put a dot. Okay. The other part of a reciprocal function is that wherever it's positive, it's positive. So you're going to get overlap. I'm not going to draw it here in these two blank spots because wherever it's positive, it should stay positive, right? So wherever my answer is positive, it'll still stay positive. You will get overlap. And then wherever it's increasing, it's now decreasing. So it's going to decrease this way. Sorry, my markers. Okay. So here, I'm going to go decreasing. So it's increasing, it's decreasing, and where it's increasing, it's decreasing. So again, overlap, overlap, that's it. Now that's gorgeous. Right? So pretty. And that's everything, and we just want to answer the questions. The period remains the same, right? It's the same thing. You can just get one of those pink cycles, one there, it's pi. Vertical asymptotes is wherever the pink is, which is actually easier. It's just every pi. 0, pi, 2 pi. So that'll be x equals, and it'll be every k pi. Oops, sorry, I don't need a denominator, where k is an element of integers. Okay. No max, no min. And then domain, again, it just relates back to here, right? So look at the asymptotes, and we're going to say x is an element of real, and x cannot equal those guys. So k pi, where k is an element of integers. And then my range would be anything. That's it. So your homework for this section is to memorize these graphs. I mean, understand them. Right? It's better if you kind of understand where they came from. So you always know how to figure out each one of the graphs if you know where it came from. So you shouldn't have to memorize too much. And then from the graphs, you should be able to answer any questions. Like, what's the domain? What's the period? Where are the asymptotes? Right? Sometimes we ask you to graph it. Sometimes we just ask you the questions and you graph it on the side for yourself. Like if I was asked what the asymptotes for this and they didn't ask me to graph it, I would sketch something. I'd be like, oh, I know what it looks like. Don't spend 1,000 years sketching it, but I'm like, oh, I know because its sine is this and tan is, oh, and I kind of get it from there. Right? So sometimes we ask you to graph it, sometimes we ask you questions, but basically understanding those graphs, those 6 graphs. Clarification, nothing?